B6. Let's go into the next slide. You know about, let's begin with this, Ankita. Let's say that in your city, you take taxi rides, and I am not a very good.
So I can't hear you.
Can you hear me now, Ankita?
Yeah, now I can hear you.
Okay. So in your city, let's say you take taxi rides, and you know, if you sit in the taxi, if you use the taxi, if you say book the taxi, the amount you have to pay is $5. Okay, and per dollar per kilometer, the distance that you travel per kilometer, the price would be ₹2 per kilometer, right? This is the fixed cost, fixed fare,
Yeah.
and this is the variable fare. It depends upon how many kilometers you travel. Now tell me, suppose the distance traveled is 15. What will be the total fare?
15 kilometers, so 15 into 2.
And you are using the taxi, right? Fixed fare is
Yeah.
so it'll be 5 plus 2 into 15, isn't it?
Yeah.
So how much is it?
35.
35. Very good. If the distance traveled is let's say 22 kilometers, what will be the total fare?
22 kilometers, so 5 plus 22 into 2.
Very good. 2 into 22. Let's write it in this pattern only, this manner, this form, this format. So it is going to be 71.
49.
Oh yeah, 49. Sorry, I took it as 3. 49. Okay, here one last thing. If you take, if you travel for a distance of let's say 13 kilometers, what will be the total fare?
5 into 2. No, 5 plus 2 into 30.
And that's gonna be 31.
65.
Huh?
Oh, it's 13. Okay, 1 minute.
31.
31. Yeah.
So in all of these expressions, Ankita, in all of these expressions, which one do you see changing? This one, and this one. What is changing and what is not changing?
Only the distance is changing.
Distance is changing. This is fixed. This is fixed. And this is variable. Right? So,
yeah,
in case the distance is x, what will be the total fare?
Distance is x. It will be 5 plus 2 into x.
5 plus 2x.
Oh, yeah.
So, you see, you understand here that this 5 and 2 are constants. What are they?
Constants.
And the x is the variable.
Yeah.
Are you getting the picture? Fantastic. I'm gonna clear this, okay? So you before clearing this, I would like to tell you that this is nothing but an algebraic expression. What is it? Algebraic expression. This is called algebraic expression. Algebraic expression means that you have a combination of constants and variables. Okay, combination of constants and variables. Are you getting the picture? Now, what does that plus mean? Okay, I'll rub it and you know. So your algebraic expressions could be very complex to very easy. For instance, even this is an algebraic expression, just 5. I wrote just 5. This is an algebraic expression. The variable is not visible. The variable is not visible in this. This is an algebraic expression, the one you just saw. This is an algebraic expression, 5 minus 3x plus root x. This is an algebraic expression, root y divided by y plus 1. Are you getting me, Ankita?
Yeah.
This is an algebraic expression, 3z cube minus z power minus 2 divided by cube root of z plus 9 z power minus 7. It could be any expression wherein constants and variables are involved. All of these are algebraic expressions. Clear?
Yeah.
Fantastic. Now we are learning polynomials. Polynomials are not just any algebraic expression. There has to be some specific qualities in an algebraic expression to become a polynomial. But first, before going into that, let's understand the meaning of terms, and let me erase this one. This is way too vicious. You write a sentence in English, English language, Ankita. You put space in between words, right? So, the space between words and the addition and subtraction, basically just addition. Addition is the space in mathematics, in mathematical algebraic expressions. Okay. For instance, if you write like this, let me write one. 3 minus 2x power 4 plus 6x cube minus 2x squared minus 7 by 3 x plus 8. Now you see how many terms, just a second, let me erase this. How many terms do you see here?
How many terms? 1, 2, 3, 4, 5 terms.
So you know about terms already without me having to say. The terms are, units or sort of, an expression which is a one-term expression, just like this. Let me write minus 4x plus 6x cube. You will always have a plus in between, Ankita. Listen to this carefully. You should always have a plus in between. What should we write under this bracket? Can you tell me?
Minus 2x squared.
Very good. You should always have a plus in between. What should we write over here?
Minus 7 by 3u.
X is x. And
X.
see, note that there is a plus which is separating different terms, right? Plus only the minus. These entities, these simple units. These entities are called terms. This is term 1. This is term 2. Term 3. Term 4. And term 5. Are you getting it?
Yeah.
Fantastic. So you understood the meaning of terms. Terms are units or entities which are separated by plus sign. Plus sign works like space in English language in writing a sentence. Plus is a space, whereas these terms are words. Got it?
Yeah.
Very good. Now, like I said, all algebraic expressions will not be polynomials. Listen to this carefully. Algebraic expressions, I will categorize. There are two kinds of algebraic expressions. One, polynomials and non-polynomials. Are you getting me, Ankita?
Yeah.
What are polynomials and what are non-polynomials? Let me give some examples. Let's say we have 3x minus 7. And here we have 3x power minus 1 plus 7. Let's say we have 5x square minus 2x plus 8. Let's say here we have 5 by x plus 3x minus 8. Let's say we have x cubed minus 4x squared. And let's say we have x cubed minus 4x. What differences do you see in the two sections? Two sort of
In the two sections, first of all, in the polynomial section, they're all raised to positive numbers, but in the non-polynomial section, 3x is whole raised to minus 1.
Very good. That's what I wanted you to figure out. Wonderful, wonderful work. If you write it in a standardized way, this polynomial, Ankita, it will look much like this. Okay, I will do 3x power 1 minus 7. What is anything power 0?
Anything power 0 is 1.
So can we write x power 0 here?
3x whole raised to 1 minus 7x whole raised to...
Can we not?
How?
7, it's only 7 here, right?
Yeah.
7 can be written as 7 into 1. And you just told me that 1 is nothing but anything power 0. So we can write x power 0.
Yeah.
Great. You must be able to visualize this. Now try to make this one in the same form, this form.
5x square minus 2x plus 8.
Minus
2x whole raised to 0.
2x power 1. There is x there. If x is visible, if x is there, the power is 1. Yeah.
Oh.
And plus 8. What about 8 part?
8 power 0. 8x whole power 0.
Very, very good. Very, very good. Okay, what about this? This is not complete. It's x cubed minus 4x square only. Go on. Let's begin. What about
X?
Yeah, the standardized form, x cubed minus Yes, Ankita, go
It's
on.
the same thing, right?
Yeah, but there are terms missing in this. There are terms missing in this. I mean, for example, we don't have a term having x. We don't have a constant term, right? So let's write those terms. If you don't have a term having x, you will write it like this. 0 into x power 1. 0 into anything is
0 into anything is 0.
0. That's why it was not there. It was not there. So we made it into 0 into x power 1. Okay, Ankita, get me?
Yeah.
And what is the constant term here?
The constant term here is 1
Oh,
or 0.
There is nothing here, right? Nothing behind it. Are you getting the picture?
Oh, yeah.
Very good girl. But like you said, in this one, if you standardize it, it's gonna look like 3x power minus 1 plus 7x power 0. Right, Ankita?
Yeah.
What about this one? If you standardize it,
If you standardize it, it'll be 5x whole raised to minus 1 plus 3x whole raised to 1 minus 8x whole raised to 0.
Okay, what about this?
X cube minus 4 by
X power?
x power
Uh,
0.
no. In the chapter of real numbers, I told you square root of 2 means 2 power half. Square root of 3 means 3 power half. Don't you recall that?
3 whole.
So x power?
X power 1 by 2.
Getting me?
Yeah.
So these are weird. These are very weird. They have negative powers and they have fractional powers, right? There is a power minus 1, as you can see. Just a second. There's a power minus 1. There's a power minus 1 here. There's a power 1 by 2 here. These are not allowed in polynomials. These are not allowed in polynomials. In polynomials, you can only have whole numbers as powers. 0, 1, 2, 3, 4. Only these are allowed in polynomials as powers. Powers of what?
Powers of 1.
Of the variable. Powers of the variable. Are you getting me? What is the variable in all of this? What is the variable in all of this?
X.
X. So powers of x should be only these numbers for polynomials. Not a negative number, not a fraction. Are you getting the point? Very good. If something like that happens, like a negative number is there or a fraction is there as the power of x, then it is a non-polynomial. Clear, girl?
Yeah.
Very good, very good, very good. So let me see what we have next. Okay. Now let me just describe a little bit of coefficients. Okay? First, tell me whether this is a polynomial or not. I will write for you. We have, let's say, 2 minus 3x plus 5x cubed minus 6x squared. Okay, standardize this first. Is it a polynomial? Do you think it is a polynomial, Ankita?
Yeah.
Okay, let's standardize. Let me tell you that polynomials are represented by this, okay, P of X. You can write P of X, Q of X, H of X, F of X, right? For polynomials, okay?
Yeah.
So standardize this, Ankita, come on, let's begin. Standardize means, you know, you have to have all the terms and you have to have descending order of powers. Descending order of powers. Highest power term must be in front. What is it going to be? Tell me.
So first, we should first standardize it and then we can write it in the highest power.
Yeah,
So
highest
first
power.
it will be, huh?
Highest power to lowest power. Highest power to lowest power. Descending order of powers.
Yeah, so highest power here is 6x minus 6x squared.
And how is that the highest power? Power on x, power on x, exponent of x.
5x cubed.
Yes, that is the highest power term. Positive 5x cubed. Very good. Then
After that, it's plus minus 6x squared.
very good.
And then it's plus minus 3x whole raised to 0.
And x is present. X is present means power 1.
1, sorry.
Yeah. And then
Plus 2 raised to 0.
2x raised to 0. If you write 2 raised
2x
to 0,
raised
that's
to
1.
0.
Right?
Yeah,
Very good, girl. Is it a polynomial? Tell me now.
it is.
It is, because all of the, just a second. All of the terms have whole numbers as powers. All of the terms have whole numbers as powers. This is 0. This has power 0. This has power 1. This has power 2. This has power 3. It is a polynomial. Great, Ankita. So you have got a good understanding of polynomials now. Now, let's understand the meaning of coefficients. What is the coefficient of x in this? Coefficient of x in this polynomial.
Coefficient of x.
Do you understand the meaning of coefficient? Let's say you have written 7 by 3x power 5. For this term, the coefficient is the number in front of the variable, that is 7 by 3. Okay, are you getting me?
Yeah.
You have, let's say, minus 2x power 7. The coefficient is minus 2. The number that is in front of the variable is called the coefficient. So what do you think will be the coefficient of x in this?
Coefficient of, in which one?
In our
7 by 3.
No, forget about this.
X has many coefficients.
Array, I am talking about x means I am talking about x power 1. X power 1 is present in which term?
Oh, 3x, minus 3x.
Yes, so minus 3 will be the coefficient of x. What is the coefficient of x square?
Coefficient of x square, what is x square? Minus 6.
Very good. What is the coefficient of x cube?
X cube, 5.
Very good. You understood this. Let's do the next exercise then. Take a look at this. Write the coefficient of x cube in this polynomial. Just find out the coefficient, okay? No need to arrange or do anything. No need to standardize it. It's okay, it's okay. We will not standardize. Just figure out.
The first one, the coefficient of x cube is minus 5.
X cube is minus 5. Fantastic. The answer for this will be minus 5. Minus 5. Fantastic. Okay, next one.
Coefficient of x is minus 2 root 2.
Very good. What about this one?
There's no x square, so the coefficient of x square will be 1.
0, 0, 0, 0. Let's try to make this standard. What is it? 2x minus 3 plus x cube. So what is the standardization? How do we standardize?
We standardize it 2x whole raised to
First, the highest
first you
power
put the
term.
1 with the highest term.
Yeah, so highest power
So
term,
first x cube
x cube. Is there a
plus
term having x square?
there's no x square.
So what do we do?
Plus 0.
Plus 0 times x square. Okay. Then
Plus 2x whole raised to
1
1
and then,
minus 3x minus 3x whole raised to 0.
so what is the coefficient of x square in this?
0.
There you go. What about this one?
Coefficient of x minus 2 by 7.
Minus 2 by 7. And what is the constant term? Constant term means the coefficient of x power 0.
Coefficient of x power 0. There's no x power 0 here.
It's not visible. It is there. It is not visible.
The 7 by x, 7x whole raised to 0.
No, Ankita, you're missing out on it. Let's standardize this. What is it? Pi by 2 x squared plus 7 x power 1 minus 2 by 5 pi. What will come here? X power 0, right?
Yeah.
Any confusions, Ankita? Please ask. Please ask. What is the confusion?
I'm just getting confused at where to put that raised to 1 and raised to 0. I'm just getting confused there.
Acha. If x is visible, like suppose you have 2 power 1. 2 power 1 means 2 is there, right? But if it is 2 power 0, 2 is not there. It's rather 1, right?
Yeah.
So if x is there, it means x power 1. If x is missing, it is not there, that means x power 0, right?
Yeah.
So we don't have x in this one now, last term, right?
Yeah.
So there is x power 0 in this, there is x power 1 in this, there is x power 2 in this. So what is the constant term? Constant term, that means having x power 0. Which one is it?
X power, having x power 0, it's minus 2 by 5 root. I mean 5.
Yes, that's it. That's it. That's it. If you don't have x, that means it's a constant term. There is no x, no x.